Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Suzanne Miller, and I'm a principal researcher in the SEI Software Solutions Division. Today, I'm joined by my friend and colleague, Bill Nichols, who leads our work in software engineering measurement and analysis. Bill has been a frequent guest on our podcast series, and we've always enjoyed having him. We will link to his digital library author page in our transcript because he has lots of things that he talks about, and you can find all of his publications there. In this podcast today, we're going to talk about Bill's latest work in cybersecurity measurement. Welcome back, Bill.
Oh, thank you. Glad to be here.
Yes. So, for those members of our audience who don't know you already, can you please tell us a little bit about yourself and the work that you do here at the SEI, and what do you think is the coolest thing about your job here?
Well, my background is in physics. That's where I got my PhD in experimental physics, which is where I kind of learned about measurement, but didn't learn a whole lot about software engineering, except that we did a whole lot of it. Not always great. I did nuclear engineering for the Naval Reactors program for about 15 years, and that's where I really learned the art of software engineering and measurement. We had the SEI come in, including Watts Humphreys, so learned from one of the very best there. After a few years of that, I came over to the SEI and started working with our team software process team, teaching software measurement and using those measurements to control your software projects and programs. And I've been here now for another 15 or more years. And my work now is leading the measurement program. I think the coolest thing about it is some of the people I really get to work with. Really an interesting cast of characters, really smart. And it's really great to be able to come in every day and get to work with these kind of people.
I love the people in your group as well. I know who you're talking about. And cast of characters, yes, they are a cast of characters. Well, most of us at the SEI would fit into that as being a cast of characters. So it's part of what makes it interesting. So to begin our discussion today, you've talked about measurement in some different contexts, but not yet about the importance of cybersecurity measurements. So what's the important thing about cybersecurity measurement, and what kinds of measurements do we use in cybersecurity, and what can they tell us about a system that we are trying to analyze?
Well, you have a couple of different questions there. The first thing is the importance of cybersecurity metrics. So that gets me down to the most important thing in measurement is not starting with the measurement, starting with the goals. What do you need to know? What do you need to do? What kind of decisions are you going to inform? And in the world today, it's hard to imagine anything being more important than the cybersecurity, because it's in everything. Everything we own is potentially vulnerable to cybersecurity. Our identities, everything. So it's about protecting ourselves. It's really critical to a modern digital interconnected world. Now, I think, what was the second part of that question? What are they?
What are they? What can cybersecurity measures tell us about a system?
There are a number of different things. And again, that gets down to the question of what aspect of the system are you looking for. The most broad categorization is everything to do with protecting information, data, and access to your system. So the metrics are typically going to be involved in understanding what are the threats, what are the potential exposures in your system, whether it's in the environment or whether it's something you could measure within the system. And it would even extend to things like, well, what is the value of what you're protecting? What are the risks if it is damaged or exposed? So there are all sorts of things you could measure. What aspect you're looking at any given time will depend. That will drive what you actually do want to measure.
So that goes back to the goal-based measurement.
It goes back to the goals, absolutely.
Yep. Okay. All right. And obviously at different points in the life cycle, we're going to have some different goals. We always want to protect access to data, access to, even things like being able to manipulate the code, All of those things, are going to have impact at different points in our life cycle. And some of them sort of are similar, I would think, to some of our software engineering metrics in terms of how many of these things have happened and how many of those things have happened. But what are some of the key differences between cybersecurity metrics and traditional software engineering metrics?
Oh, that's a great question. And I think the short answer is software engineering metrics, by and large, deal with the economics of building software engineering products.
Okay.
So you're going to be talking about things like what is my productivity, whether it's in lines of code or whether you're talking about stories to try to meet deadlines. You're going to be talking about issues of quality. So you will have measures of things like what is my defect rate, what are my find rates, how much are escaping. Those are sort of pushing into security related, but they aren't really there. When you get into security, you're really looking at things that potentially are going to expose data or expose your system to a compromise. And that there are some, there are some categorizations. For example, MITRE puts out the common weaknesses enumeration of a bunch of code-based or environment-based paths that are potential weaknesses, or the vulnerability list, which represents actual exploits. And these are the subset of those qualities that you would be worried about in software engineering. I mean, you're normally going to be worried about things like extensibility, maintainability, in addition to the functionality. Cybersecurity focuses on those that specifically relate to securing your system and your data.
So you've really started to talk about what are some of the challenges of cybersecurity measurement, one of which is, where is my data? What is it that I need to protect? I heard you say that earlier. What is it that we need to protect? What are some of the other challenges of measuring cybersecurity?
Well, one of the big problems in cybersecurity metrics is just scoping things down and getting clear definitions and standardization for what it is you're trying to measure. That is, what are the underlying concepts that you're actually concerned about? It's very hard to get a consensus on what kind of metrics you should be measuring, or what are the specific things you should be measuring in a specific context for purpose. There are lots of nuances also depending on the industry. You've got a very different scenario if you're securing, say, the software systems in your automobile versus an online bank.
Mm-hmm.
So all sorts of issues there. Now, then you have the issue of data availability. Uh, where are you going to get, and here I don't mean the data you're protecting, I'm talking about the data related to security. Things like code bases tend to be held very closely. That's why a lot of the research is using open source, because that's available. But the proprietary is very closely held, and very often you can't get good measures on the code, certainly not on the incidences that actually happen. So a lot of things are happening kind of behind the curtain that we aren't fully aware of. So we're trying to measure this system, but we're only seeing parts of the system that we are allowed to see. There's a lot more out there, and that's a whole separate problem. That leads to things like data silos, and then you have the unknowns. Because you have an active adversary who is trying to figure out, it's like a cat and mouse game. You take certain actions, they react, they try a different path. It's not a stable system. So you have these unknowns and this constant evolution as you're playing this game. So it's not really a stable field.
Okay. And so I heard two things. One is the code bases that you would want to get into to analyze how certain things happen are essentially black boxes to external parties outside of whoever owns the code. And then the second thing is this dynamism of the system, the fact that as soon as we see an exploit, we try and recover from it, we change things, and if we're lucky, we don't introduce any other exploits. But if we're not, we can exploits, vulnerabilities. If we're not, then we could still, have problems. Just because we fix something doesn't mean that everything is fixed. Is that correct?
Correct. And to be honest, we don't even know about all the exploits. It's hard to be certain that certain things haven't been out there for years and are just being quietly exploited. These things can lay hidden. So that's another challenge in the metrics. You just don't know what you don't know.
Okay. Well, it sounds like you're going to be busy for a while. Um,
Or someone will.
so, well, all right. So we've been talking kind of abstractly for the last few minutes. Can you walk us through a real world cybersecurity incident and help us identify potential measurement possibilities and how that information could be leveraged to avoid something similar or even something different in the future?
Well, let's see. What I think one of the nastiest that I can think of that's public. Part of the problem is for these incidents, a lot of times they aren't really public.
Sure.
They're going to be investigated quietly. But working at the SEI, you're probably familiar with the vulnerability or the attack, and I think it was 2015 on OPM, the Office of Personnel Management.
Oh,
So
yeah.
yeah,
My data's in
okay,
there too, just like yours.
yeah. Uh, we don't know officially who was behind the attack, but they have their suspicions. The cost of that attack is hard to underestimate. Literally, all of the QNSPs that we file, those are the forms that those of us with security clearances fill out with all sorts of personal data, were
Hmm.
were compromised. So all of that information is in the hands, presumably, of some bad actor, probably a nation state. All right. Uh, that's about as serious as you can get. Uh, what what are the opportunities there for measurement? Well, one of the things that they were able to do is they did have, to my understanding, some good records and logs. So having fine-grained data available in the system logs can help you do things like track down where was the exploit specifically, how was the exploit executed. And if memory serves, I think in that place, in that situation, it was uh, it was an access, some ability to get access to the system and then elevate privileges. It So with the data, you can try to determine, where was the vulnerability exposed, so that you can potentially remove that in this system and harden other systems. One of the lessons from that one is probably the importance of doing things like having two-factor.
Hmm.
Uh, those are the kinds of information you can get. So I think having the granular data, uh, having robust access management in place, and being able to trace. Another thing that I would think of here is, from an operational standpoint, one of the things you can do is you can be constantly monitoring the network so that you can understand what is the normal profile of network activity, where the IP is
Mm,
coming from, and by monitoring this sort of information, you can identify outliers. Often you can identify IPs from suspicious sources.
gotcha. So there's a combination of developmental things like monitoring in terms of the code base, looking at access points. Where are the access points that are available in the code? Can we make sure that those are hardened, as you said, um, to being to having actions that we don't want to happen?
Right, so you have a combination of being able to look at the source code, you can look at designs, you can look at the operational characteristics like the network, and then forensically, you can try to go through some of the logs and try to understand how exactly was this exploit uh, executed. What part of the system did they attack? What was the exposure or the attack surface?
Okay.
That helps you get
And,
better
and
for the
so
next time.
So one of the things that I heard you say is that we don't have a lot of standards in this arena for measurement. So when I think of standards, I think of things like, in this case, I would think of having standards for example, how we comment code that is meant to that deals with, say, PII, private data, or how do we comment code that is going to make the data available for access,
Mhm.
right? Are those the kinds of things you're talking about, that there's really no standard for that, even though those are things that I, as a software engineer, would think about doing to help make it easier for people to find where there was a vulnerability if something does happen? Am I on the right path, or?
Yeah, you're on the right path, but I think it's even more meta than that. Even something like the common weaknesses enumeration has a lot of issues with duplications and redundancies, and it's It's certainly not perfect, but it's probably the best thing we have right now for
Mm,
categorizing the data. Then you have these other questions about, well, what exactly should you be measuring on the network? Uh, there are certainly things that people use, and there are things that have been found useful, but the research doesn't have like a gold standard. So if you take a measurement, you know exactly how that measurement was taken at different locations. What does a mean time to recovery really mean? Just as an example. Well, that depends a lot on how you count.
sure.
So that presents all sorts of
Yes. So
problems.
let's just take that incident, right? The mean time to recovery has multiple components. One of them is when did the incident occur, and what
Which you
does
may not know.
recovery, what does
Yeah,
recovery mean? Does recovery mean back to a normal state, or does recovery mean back to an acceptable state, right? Those may not be the same thing, right?
exactly. And those are the kinds of uh, semantic definitional problems you run into if you try to aggregate data and look at trends across the industry. A lot of data cleaning.
Yeah, yeah, I was just thinking about that. The whole world of data cleansing has just really exploded between AI and cybersecurity. The people that enjoy doing data cleansing should have jobs for a long, long time. Um, so, are there solutions or approaches that you've run into that you would recommend for cyber practitioners in the field who want to capture metrics of the code that they own and the systems that they are operating?
Well, the best advice that I would give right now is a little on the generic side because it's hard to be precise. Everything depends on your context, but always start with the objectives of what you're trying to measure. That's always what drives what you should measure. So try to understand what is the concept, what is you're actually trying to get to, and then look for the mechanisms that you can get indicators. And rather than just collecting a bunch of data, I always recommend, try to do some sort of validation. Make sure that the data you're collecting is actually consistent. To the extent possible, you would like to automate the data collection. You'd like to see that the data, does the data have some variability, some trends? You want to understand what is the normal behavior. How would you recognize outliers?
Mhm.
Anomaly detection is often one of the clues that there is an exploit or vulnerability out there. As far as frameworks, uh, there are a couple, like from the CERT has the uh, capability maturity model for cyber, which is worth looking at. The NIST has some standards out there. They have some strengths and weaknesses, but that is certainly one of the things that is approachable. But I think the most important thing is when you're measuring, know what you're trying to get at, and make sure that you define the measures that you're actually using to get at that underlying concept very precisely so you can reproduce the measures consistently.
So what you're talking about is actually a framework that we've been using at the SEI for decades now called GQIM, Goal Question Indicator Metric,
Exactly.
right?
Yeah.
And so that's one of the things we will reference in the transcript because it is not only applicable to cybersecurity, it's applicable to measuring anything that is of interest. And let's face it, measurement costs money. One of the reasons for GQIM and for narrowing down not just what you can measure, but what you should measure is so that you don't spend money on items that aren't going to give you answers that are going to be useful to your context. So that's a whole
Oh,
economics aspect
there's a huge
back to software engineering.
Yeah, and that's another one of the big challenges in the cybersecurity metrics. I mean, one of the things you're trying to do with the cybersecurity metrics is secure your system. How much are you willing to spend to secure it? I mean, am I going to have a little master padlock, or am I going to have a bank vault? Big difference in cost, and the cost of cybersecurity can go way beyond a bank vault.
Sure.
So unless you have some consistent ways of measuring, even getting that trade-off is going to be a real challenge.
So one of the things that I've spoken with some of our other colleagues in CERT, there's been a lot of work in the last few years on threat analysis. And is that one of the sources for the kinds of measures, the kinds of goals? If I've got a goal to keep my system secure, then one of the things I need to know is about what kinds of threats are there to my system. The threats to a banking system and the threats to a healthcare system may have some similarities, but also probably a lot of differences. And so is that an area where that's something that we don't, in software engineering, I don't really have a threat space for software engineering, but that seems like that's an area that's of difference, where cybersecurity is looking at those external kind of factors that I may not be as conscious of when I'm thinking about software engineering,
Yes,
in
yes,
a traditional
exactly.
sense.
The part of the big difference, cybersecurity is a system. It's not just a property of your system. It's not just a property of your software. It is really a property of your system in use. And one of the things I definitely would recommend is, before you set up a measurement program, you really have to start with things like looking at doing a threat analysis, examining the attack surface, because that gives you some real understanding of what are the sort of things you really need to focus on for your measurement goals.
Well, and also, how much should I spend, right? If my attack surface is very limited, I have a lot of air gaps and things in my system that really limit, where there could be vulnerabilities. That's a different case than something that is out on the web and available, to the whole world, that presumably needs to be. And that's gonna change the cost. That attack surface is going to change the cost of collecting the measures, correct?
Oh, absolutely. And you're from the same generation as I am, so you've probably seen many of the same examples of these systems that were perfectly useful in their day, because they were on this air-gapped PC before we had Wi-Fi networks. And then these things somehow ended up on network systems and became vulnerable. And that kind of problem just repeats over and over again as we've become a more and more connected world.
Agreed.
So it's not just where the system is today, it's every time you move a system into a different environment, you have to reconsider the entire security posture. One of the nice things about the GQIM approach is that the environment is one of the explicit considerations you go through in the steps through for understanding the measurement that you need to do to answer your questions.
Right. And when that environment changes, that could either directly change the measures or indirectly change them. Possibly not at all, but chances are you're going to have some change.
But you always should look at it. The context, as
Yes.
they say, context is king,
Context.
or queen,
Yep.
depending on your preference. But
Yep.
the context can change everything.
Yep. Agreed. So a big part of our work as an FFRDC is transition. So if you can sort of highlight what are some of the things our audience can do to learn more about cybersecurity measurement, how to implement cybersecurity metrics, what resources, you mentioned NIST, you mentioned the MITRE CWE. What are some things either from the SEI or other places that you would also suggest that people look at?
Well, one of the practical books I would recommend is look up Carol Woody and Nancy Mead's book, Cybersecurity Engineering, A Practical Approach for Systems and Software Assurance. So there's a lot of great technical information in that one. For a more general measurement approach, you might look up Doug Hubbard's book on cybersecurity risk. He goes into a lot of examples on how to do estimates without a ton of data. So it's a very, very principled economically practical approach.
Okay. I don't know Doug's book. I may have to look that one up. But what's next for you? What are you working on now? What are we going to be able to bring you back to talk about in the future?
Well, I have the next stage of a research program we've had going for several years on extracting data from the DevSecOps pipeline and the surrounding information systems, like the ticketing systems, to get a better handle on software development and productivity and tracking. We call it ACE TOPS. We're taking the automated continuous estimation using the data we collect to estimate the completion dates, schedules, and uncertainty in delivery for software engineering. And we're working on transitioning it with the kinds of things that would include the data collection tools, the types of visualizations you would like to have available. And it's trying to take a lot of the approaches that you're seeing in modern software development with gathering all of these metrics, but it's a much more focused approach on understanding how do we use this to control software projects and larger software programs and take action at a reasonable time.
Oh, excellent. Well, that sounds like you're going to be busy with that, and you're going to be busy with cybersecurity measurement. I can see that. So I want to thank you for talking with us today, and I look forward to talking with you in the future as well, as some of these other things emerge. For our audience, we will include links in the transcript to resources mentioned during this podcast. And finally, a reminder that our podcasts are available pretty much any place you can access podcasts, including SoundCloud and Apple, and my favorite, the SEI YouTube channel. If you like what you see and hear today, please give us a like. And if you have any questions, please don't hesitate to contact us at info@sei.cmu.edu. Thanks again for joining us.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, TuneIn Radio, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.